Final example. A chemistry student is required to determine the concentration of a solution of hydrochloric acid. First, she makes up 250 ml of a standard solution. This solution contains 1.358 grams of sodium carbonate, 20 ml aliquot of this solution. Let's start drawing up a flow chart just to keep track of what is happening here. All right. So chemistry student required to determine the concentration. Yep. So 250 ml of a standard solution. This solution contains 1.358 grams of sodium carbonate, molar mass 106 from last time, and putting it in a 250 ml flask. Okay, and I'll draw it in the flask because I'm in paint here. That's a terrible flask. Now, you're putting it in the flask, you take a 20 ml aliquot, so this is aliquot, concentration, same, moles decreases, and you're adding it to, or you're taking 20 mils of it, and you're putting it in the conical flask. Right, then you have an acid. I haven't even told you what acid it is. Oh no, hydrochloric acid. And you are basically adding 20.24 mils of the acid. Now, I'm going to take this flowchart back to Word so we can start answering the questions. Write a balanced equation. Okay, so usually we would do this when we want to work out the mole ratio, but that's okay. We've got to make sure we're answering the actual question. So we're going to copy the balanced equation, nice, that I wrote up here. But we're going to put our states because it's an actual question now. So for part A, we want to put our correct states in there. Aqueous, and this will be a gas. And we all know that water is a liquid and salt is soluble in water. All right, part B, calculate the concentration of the sodium carbonate solution. All right, so we've got the mass there, so we can work out the moles of the sodium carbonate solution. A lot of stuff I can copy from up here actually, which is nice. We want to do mass over molar mass. All right, here we go. Now, it's not 1.34, but it's close, 1.358. We're not very creative, are we? 358 divided by 106, and we get 0.128. Wow, frightfully close. All right, and that is not the answer because it wants concentration. So we all know that concentration will have to be, is this in 250 ml? Oh, perfect. The concentration is moles over volume, okay, and the moles are 0.0128, and the volume is 250 mils, which is 0.25 litres. There we go, and that equals 0.512, capital M. All right, that'll be the same concentration as in the 20 mils, so that's good. So that even though they haven't asked us to work it out in a particular volume, we know it will be the same because aliquots, they stay the same. Part C, find the concentration of the acid as indicated. Okay, so in this case, we've got to work out the moles of the sodium carbonate that reacted with the acid. So we've got to work out the moles of the sodium carbonate in the 20 mils. And this will be C times V. And in this case, our C is 0.0512 and our V is 20 mils, 0.02. 0.00102. Find the concentration. Okay, now we've got to go moles of the unknown, which is HCl. through the mole ratios, and then that's the moles of the HCl in the 20.24 mils. Just helps you keep track and also get consequential marks. Equals 2 times the moles of the sodium carbonate. Excellent. And that will be 0.00205 or 2049. No, 205 mole. Then we've got to get concentration, and the concentration will be equal to N over V, and that equals 0.00205 over the volume of HCl used is the average titer, which they've worked it out for us, and we can simply calculate that. Excellent. Equals 0.101. Now for part D, okay, if sulfuric acid of the same concentration was used, what effect would this have on the volume of the acid? All right, so we know that sulfuric acid is different to hydrochloric acid in that it is diprotic, which means that the same concentration will have twice the number of hydrogen ions. So that means the mole ratio will be different. Let's work it out for sulfuric acid. So the mole ratio in this case, is Na2SO4 Okay, so in this case, it's actually a 1-to-1 mole ratio. Just got to feel like it's not balanced. No, it is. Okay, so it's the mole ratio is 1-to-1. The mole ratio between these two is 1-to-1. Is 1-to-1, and they're asking the volume of the acid, and therefore less acid needs to be added. The volume of H2SO4 would be half of the volume of HCl. So in other words, because you're adding a diprotic acid, so you're adding something which has twice the amount of protons, you would need to add half the amount, which means that we would add 10.12 mils. Or, what should I say? About 10.12 mils. All right. Now for part E and F, these are some annoying questions which are actually about errors, okay? So in this case, the student rinsed the burette with water instead of HCl. Explain the effect that this would have on the calculated value of their HCl versus the actual. Well, let's have a think about this. If they rinse the burette with water, the concentration of the HCl would decrease, and therefore a greater volume would need to be added according to concentration equals moles over volume. If the denominator increases, so if the volume increases, the calculated concentration decreases. But I mean, this makes sense because you think about it, you're actually diluting the HCl. You're going to calculate the concentration as lower. So therefore, calculated concentration of HCl is less than actual. So let's have a look at the next one. A student rinsed the pipette with sodium carbonate instead of deionized water. Explain the effect. This is actually a bit of a rigged question because you're supposed to rinse the pipette with the sodium carbonate. So I'll actually just change it. Rinsed the conical flask with sodium carbonate instead of deionized water. Okay, so this would increase the amount of sodium carbonate in the conical flask. You'd have a greater number of moles of the sodium carbonate in the conical flask. Therefore, more HCl would need to be added to reach that neutralization, to reach the equivalence point. Therefore, according to the following, copy and paste, a lot of copying and pasting here. According to C equals N over V, if we need more HCl, the calculated concentration is less. Therefore, it's less than actual. So hopefully they made sense. Yeah. Stop recording.